I'm Neeraj Jain. I work as an engineer with Stubhub at San Francisco. And I'm going to be talking about how we solve some of our data deduplication problems at Stubhub. And here's my email in case you have any questions that are left unanswered during today's session. Please feel free to reach out to me after the session or get hold of me outside this room. So this is something about myself. I'm a postgraduate from Indian Institute of Technology, Kharagpur, aka IIT Kharagpur. I worked with IBM for 5 years at Bangalore in India. I also worked with Charles Schwab for 3 years, and that was in city of San Francisco again. And that's where I had my first touch of Lucene. That was more at the library level, not at the Solr level. And with Stubhub, I've been working for a little over 4 years now. And I started working at Stubhub as a lead engineer for the search team, and then later on I moved to work with a catalog team. And that's where we are using Solr as well. And I'm going to get into some more details of how exactly we are doing that. And excuse me. Besides my full-time job, I also do some app development. And if you are ever in San Francisco and you're looking for the time for your next ride, feel free to download the Ride On app. It's on Android and Apple Store, and it's free. And here's something about the company that I work for, Stubhub. Stubhub is world's largest ticketing marketplace. It's world's largest. And what we do mainly is we enable access to events. Basically, it's a marketplace where buyers buy the tickets and sellers sell the tickets, just like eBay. And we want to be more. Basically, we are right now in the ticketing business, and we are growing more into to help fans discover the events. Some more fun facts about Stubhub are, it's an eBay-owned company. eBay acquired Stubhub in year 2007. And we have over 25 million users and still growing very strongly. We sell 1 ticket per second. And excuse me. Something is happening. It's like, I think the clicks it's auto-forwarding. Sorry? It's advancing without me hitting the buttons. See? Yeah, it just moves. See?
Oh, I see. Self-running slideshow as surplus. Still advancing?
No. Okay. So, hope it works better now. So we have over 25 million users and still growing. We sell 1 ticket per second and 8.5 million page views a day and 3 million additional page views on mobile. We are growing very strongly on mobile as well. And we have 10 million active listings for sale in sports and concerts, sports, concerts, and others, like theater, festival tickets. And we have approximately 1 terabyte of data processed monthly by analytics infrastructure. And this is going to grow more as we grow further. And 3 million sequence executions to serve these 11.5 million page views a day. Anyways. So here is a little history of how we have been using Solr at Stubhub. We started using Solr 1.2 in 2010. And in 2011, we upgraded to 1.4, mainly to leverage on the multi-core functionality. And later that year, we did a major upgrade to Solr 3. That was basically for to avail the support, geospatial search support from Solr, as well as for group by functionality, which is also called field collapsing in Solr. And before using geospatial search on Solr, I was using a plugin that was provided by Jain. Last I heard that they have discontinued the support on that plugin, so I think that was a good move. And on a good part of 2012, we were on Solr 3, and then later moved on to Solr 4 for the NRT feature. And come 2014, we are already on cloud, and we're using other open source technologies on the search stack like Avro, Zookeeper, and a few more other things. I'm not going to be able to get into too much detail on the search infrastructure because this is not about search. Today, it's not about how we do search at Stubhub. But in case you have more questions about how we about the search stack at Solr, please reach out to me after this this talk. So here's the agenda for the rest of the talk. I'm going to be talking about the content ingestion use case for which we are using Solr today, and what are the challenges that are posed in the content ingestion use case itself, as well as in the deduplication use case, and how we solve this use case in the past, like what our legacy solutions are, and what was our new approach. And then if time permits, we'll also get into some of the slides where we have the results. So here's the content ingestion use case. As you're aware that, Stubhub is an online marketplace for tickets where we provide the services to buyers and sellers of tickets for events. So the content so what we do is we basically, people do transactions against the event catalog. And right now what we have is we have an event catalog of approximately 100,000 events, and that's all of them are hand curated. So, and as I said earlier, we are getting into also the discovery business, and 100K events are not going to help us, get there. So we are working on ingesting millions and millions of events, basically, any event-related data. And hand curation is not going to take us there. So what we have done recently is we have enabled automatic ingestion of events to a certain extent. And whenever we automate any manual process, it comes with its own challenges. And we have to solve those challenges to make sure that we maintain the data quality. And at Stubhub, we do not mess with the experience that we provide to the fans. So how does the content ingestion process start? It starts by exposing an interface using which we can opt in the data. Now that interface can be in a form of a feed. Like we can download a feed from ESPN, which will provide us the MLB 2015 events, all of them. So that's just one use case. Now we have feeds that are coming from more than 50 partners, and we are basically working on more partnerships. The other form of getting the data is basically if you have an input form of internet where people can go and fill in the event information, and that does not restrict to the end users. We have the employees, basically content admin, and partners who also enter that information. So it doesn't really matter where the information is coming from. Ultimately, what we get is an input record that then goes through the series of steps. Now, for the sake of this discussion, what I've done is I have bucketed these steps into three major categories. One is pre-deduplication. Then the second is the deduplication itself. Deduplication is highlighted in a different color because I'm going to be getting into further detail of deduplication. And the third one is what exactly happens after deduplication. So what happens before deduplication is we normalize the document. When I'm talking about the document here is basically it's an event record or a venue record or people who are performing at an event, like performer artists or sports players and band. So what we do is, once we get the record, it's a document, and we normalize the document, basically, trim additional spaces and those kind of things, and then we pass it through multiple filters. So these filters can be English stop word filters or document entity-specific filters, which basically depends on the domain itself. And then the two steps are really important. Classification is, let's say when we are processing a venue document, then we like to classify that as, for example, if it's a bar or a restaurant or a hotel or a major venue itself. Because the better the result from classification step is, the better the results will be from the deduplication step, as well as better fan experience we can provide. For example, if you're on the site and if you're looking for a restaurant near a venue, That's how we basically find the restaurants near a venue. For example, if you are in the AT&T park watching a baseball game and then you're looking for the bars near that, that's exactly how we find the bars near a major venue. And for geocoding, we rely mainly on the external services like Bing and Google geocoding services. And the output from geocoding is very important, one for deduplication and second for providing the features like events near you on the site. So with the geocoding, mainly what we get is we get a normalized address back, and more importantly, what we get back is the latitude and longitude of the venue. So once we basically cleanse the record and get some more information from after these 4 steps, then we pass it through something called our deduplication system. The job of the deduplication system is to, for this input record, find out if there is any matching record exists in the data store. If the matching record exists, then the post-deduplication step will take required action. For example, if the record exists, but the new record has more information than the old record, then the post-deduplication stop, it will basically update the existing record based on some business rules. It will basically what we call is enrich step. And if it finds out that there is an exact record exists in the data store, and this new record is not going to be adding any more value, it's just a noise, then it's just the new record is just discarded and flagged as duplicate. And if we are not able to find any duplicate record in the existing data store, then basically the post-deduplication step will be an insert process. And in some cases, our deduplication system is unable to clearly say that it's an exact match or not. It'll say, I'm able to find out some record, but I'm not really sure if it's an exact match. And in that case, we flag the record for manual review, where an admin will come and take a look at the record, and it'll say basically it's a duplicate or not duplicate. Okay, it's happening again, by the way. Yes, this is the next slide. So the challenges that we face in the deduplication system is basically how we design the deduplication system now, right? Any system that we design is basically, we have to find out like what the system boundaries are. So in this case, our system, basically our domain is event catalog. And when I say event catalog, it's events and related entities like performers, venues, and the related entities for the performers and venues. For example, if it's an artist, then we will have entities like albums and tracks, okay? And when the system is built, like what exactly do we expect from the system? What we expect from the system is that it has to be able to support the real-time processing and batch processing. Let's just see. It's okay for now. Oh. It's okay for now. It just happened once again. It has to be usable by a real-time processing system as well as from the batch processing system, and I'll give you my reason why. And in case when it's used by the real-time processing system, that's where we have to compromise, where we emphasize more speed or data quality. In a real-time system, when you're as an user, when you're entering data, you don't want to basically wait forever to determine, for the system to determine if it's a duplicate or not. That's where we basically emphasize more on speed versus data quality. And in case of a batch process, that's where we have to emphasize more on data quality, because it doesn't really matter if the batch process runs for 1 extra minute, but if it's able to cleanse the record properly, if it's able to guarantee the quality, that's where we go for. That's what we go for. So in the legacy system, how we use deduplication is, so the record is coming from either a feed ingester or a batch job or UGC, it doesn't really matter. The client is basically the record processor, which invokes a deduplication module's get duplicate method, okay? And this is basically tightly integrated. I'm talking about the legacy solution that we had. So it's tightly integrated into the process. And the call is basically to gather duplicates. Now, assume that the input record is a venue record. Then this deduplication module, what it does, it goes against the event DB, which in our case is a MySQL DB, relational database. And it gets the subset, basically, few documents. Let's say we have like 1.5 million venues in our data store. And what it does is it says we have a function in MySQL which can do the lat long range-based queries. So what it says is that, give me all the venues that are within 1 mile radius of this particular latitude longitude, and return me at the most 1,000 venues. Okay, so what you got is from 1.5 million venues, you got at the most 1,000 records, which you then process through the next series of steps. Then for each document, basically for each record, then you take each field, and then what it does is it normalizes each field. For example, for the venue deduplication, we use name and address. And it will take name, it will normalize that, it will apply multiple filters. When I should have said filters here. It applies stop word filters, English stop word filters, it applies venue stop word filters, and many more. And after that, it computes a Jacquard similarity coefficient, which is used basically to determine how close two strings are. So it takes the name from the input record, and then it takes the name from the output record, and both the strings they go through the same series of steps, normalizing, filtering, and then a score is computed. And if score is good enough, basically if it's above a threshold, then it is considered as a potential duplicate, okay? And if it matches the real high threshold, then it's considered as an exact duplicate. So it does that to all the documents, and then returns the list of duplicates back to the client. Now you can see that there is a bottleneck here. There is very little we can do to improvise this. And the implementation I can see is very preliminary, very rudimentary. So what we thought is, let's take a new, let's look at the problem and how we can make this whole deduplication stuff more efficient. Okay, so then what we did is we modeled the problem and say, okay, what we are doing, the first step is we are trying to filter the documents based on geospatial distance. And then what we are doing is we are also filtering the documents based on the category. For example, it's a bar or a hotel. You wouldn't want to deduplicate bar versus a hotel. Okay, it's happening again. And then what you do is then you emphasize on, once you have filtered out the documents from, let's say, 50 documents you found now that are within this proximity of this venue and that belong to the same category, now you need to basically do a more sophisticated matching based on certain fields. Now, for example, for a venue, you would say, you don't want to match Starbucks versus speed, right? You want to basically make sure that, both the strings say Starbucks at least. And address is, for example, you will find, for example, 10 Starbucks on one street. I don't know, when you come here, it stops. Just stay here probably then. So then what happens is, you would find more than one Starbucks. See, this is happening again. You would find more than one Starbucks on the same street. So what will be similar in those venues is, those Starbucks coffees is, their street address will have the same street name. For example, 101 Market Street versus 901 Market Street. But what will be different is the street number. So that's exactly where we put the emphasis on. So now what we have determined is, from the address component itself, we have to separate out the street number and street name, and then boost on the relevant fields. So in this, in venue deduplication case, we will be boosting on the name of the venue and the street number of the venue. And this, basically, we have to, once we do coding and the initial analysis, that's where we have to fine tune, like how much boost is needed and what score is acceptable and what score is not acceptable. Okay. So here is some of the data example. So for example, once you do the once you generate the subset after geospatial, after the proximity search, this is exactly what we got. For Milpitas library, 2 different feeds were giving us 2 different addresses, 160 North Main Street and 40 North Milpitas Boulevard, right? Now, if you were to filter on these 2 fields, you would say that these 2 are entirely different venues. But now, if you look at the name is Milpitas Library, and the distance between them is less than half a mile. Okay? So when we run it through the new process, and then we say that both of them are category. Okay? So basically, it has already passed 2 of the steps. Third thing is, one of the feed gave us Milpitas Library, and the other feed gave us Milpitas Public Library. So this is exactly where we use Solr's text similarity, that it will find that these names are similar. They don't really have to be exact, right? Because when we are getting the data from different sources, it's they're not going to be the same. Okay. Now, what we were doing in the legacy solution is we were using Jacquard similarity coefficient to determine how similar two strings are. And so there are multiple algorithms that we can use to determine the string similarity, like edit distance, which is Levenstein distance, and Jacquard. And within edit distance, Solr provides multiple other algorithms like JW, Haro, Winkler, I guess. So the point I'm trying to make here is that once we model the problem correctly, and then we can fine tune what exactly, which algorithm is really working and which is not working. In our case, luckily, the Solr default VSM vector space model search score that was being provided, it just worked well for us. It was, at least it worked better than the legacy solution. So with this, how we integrated that in our application is something like this. So what we did is, for the deduplication, we said, okay, this warrants for us to have a system that can be developed, deployed, tested, and optimized separately, completely different from the main process. Okay, it can be scaled completely different. If you want 10 boxes for deduplication versus 50 boxes, you can do that without impacting the main process, our clients. Okay, so what happens in this case is the top layer remains unchanged. You still have the client, which is the record processor, and the database is still the same. What we also did is we exposed this as a service, basically exposed a REST endpoint on top of this. So client just makes a REST endpoint call, and this dedupe call can be for and this dedupe, we have multiple implementation of this deduplication service. One for example, venue documents, one for event document, and the third one that we're working now is the performer matching document. So at this point, we have 2 implementations of this service already. And then how it works is for each service, we need to write a query builder. And this query builder will be taking a collection of filters. Now, filters are basically for venue. You would be working on name, address, city, state, zip code, and you can have as many as you want based on how you find in your system. For if this diagram, I were to prepare this diagram for event deduplication system, then the filters that I will put in place is event title, event venue ID, and the start date and start time of the event. So in any case, once so deduplication service gets a query, basically, which we put in the Q parameter for when we do a Solr query, and the query executor then executes the query against the Solr index using the select endpoint. So nothing crazy over there. And then we have this scorer. So what we get from Solr back whenever we do a query is the default score based on TF-IDF, right? Term frequency, inverse document frequency. And we also get a distance. Basically, using the geodist method, we also get the distance back from this query. Now, when we looked at the results, we found that the documents that are really at the top of the list are not really relevant, not always really relevant with our input record. There are some of the records like that are in 3rd or 4th in the order. They were more relevant than the first one. So then what we had to work on something called a composite score based on the string similarity, this Solr score and distance. So then basically, we had to fine tune, look at the result and fine tune what Solr score and what distance, which combination is the magic combination that works for us. So we came up with multiple sets of saying, for this score and this distance, if this is the range, then the document is going to be exact match versus a possible match versus a no match. Okay. So then what happens is in the end, the client gets the result back, results from the deduplication, and then what it does, it takes necessary action to upsert, which is basically insert or update the record based on whether a matching record exists in data store or not. In parallel, what we also have something called index updater process, which pulls the changes from the database that are, so there are other flows that are updating the data store as well, which are not captured in this flow. Now, to make sure that this dedupe index is always up to date and is in sync with our event DB, we have to have this process. We have to have this process that pulls those changes and keep this deduplication index in sync. So here is the very simple deduplication service interface as a generic interface, which has a method called find duplicates, and then we can basically implement it for any of the entities within our data model. And dedupe option is a way for client to tell the service that give me I'm interested only in exact duplicates or possible duplicates. And for now, we have only one connection. The only reason it should fail is if it's not able to interact with the index. Here are two implementations, as I said earlier, that we have venue service and event service. So there is, again, nothing fancy here. They're just plain implementations. So one more thing is, so once we build and deploy this system, right, the challenge that we faced is the size of the index is always changing. It's growing. And the score that we get back from Solr is always dependent on how many records you have in your index, because it's term frequency and inverse document frequency. So with this, it was really, really hard for us to benchmark the deduplication module itself. Then we realized, do we really care about the IDF part of this whole TF-IDF similarity module? And so what we did is we took out the IDF part and had our own implementation of TF similarity and tested it. And it worked well. Basically, what we needed is the absolute score. We don't really care about how close this document is as compared to other documents. We just want to find out whether this input record matches with any document or not, and how good that matches. We don't really care about the comparative study. So that's where our TF similarity works better than TF-IDF for us. Auto commit setting, feel free to change yourself, but this is the magic number that worked well for us. And then there is one custom post filter that we had to do. That was mainly for, at the time of this developing this module, what we experienced is when we use geofilled function to filter the documents based on distance, it adds like 30 to 40 milliseconds per query, the queue time response field. I saw that if my queue time is 30 milliseconds, and if I use geofilled, irrespective of whether I use cache and cost or not, cache and cost parameter or not, it was always, it was giving poor performance. And if for the real-time system, that 20 to 30 additional milliseconds were expensive for us. So what we did is we had our own plugin where we collected those 50 or 20 records that we got back after the initial matching and filtered them ourselves, and it worked well, better than geofilled. I don't know if it's already fixed in the latest version of Solr or not. And we also have a custom update handler. So what we do is, we have the venue and event record, for example. And venue and event record, there are basically organic fields. Like, for example, street address of a venue is basically an organic field. And as I explained in the earlier slides, that we have to boost on the street number as compared to the street, as opposed to the street name. So this is the place where we split one field into multiple fields or join multiple fields into one field. That's how, if we have multiple clients updating the Solr index, they don't really have to worry about all this logic. So all of this logic is encapsulated in this venue update processor factory. So the sample output from after we deployed this was that there are sample venues, for example, Jillian's Billard Club and Jillian's. As you can see, like, the address is similar and the name is similar, but the score, the similarity score between these two records is 1.5, and the distance between them is 5.6 kilometers, right? So based on our settings and testing, this distance was not acceptable to say that these two venues are similar or not similar. To certify that one venue is similar. So 5 is basically beyond the limit. Similarly, these two other venues were, even though you can see that the Lush Lounge and Lush Lounge, they are exactly the same name. That's why you get a very good score, similarity score. But just because you get a very good similarity score doesn't really mean that these documents, these venues are same. On the other hand, if you take a look at this, Hadley Club at Hotel Dianza versus Hadley Club, you don't see a very good matching score. but the distance between them is 0. They are both at the same address, and the classification system classified both of them as, okay, just 1 minute. The classification system classified both of them as a club. So these slides, I think, will be shared with everyone. I mean, feel free to look at the rest of them. This is my summary slide. What we discussed is I described the content ingestion use case flow and what the challenges that we faced, deduplication, and we went into the details of how the legacy system was built and how we took the approach to solve this problem. And the next steps that we are thinking is for our batch processing, how we can leverage big data. Right now, our data size is not too heavy, so big data, that's why we are not going towards big data. And the next thing, as I said, we are implementing the performer matching service. And then we have to also implement deduplication for internationalization, international data. And we also discussed the results slide. I really thank you for your time. Appreciate it. Any questions? I think we are already over time. I will be able to take the questions outside, please. They have already shown me the red paddle. So thank you very much.